This presentation just shows you some notes on the use of epidemiological and toxicological data for risk assessment that we discussed in this working group, because we started to sit in a room with toxicologists and epidemiologists somewhere in beginning 2019. And the aim was to look at how we could more use the epidemiological data and risk assessment. We traditionally have a lot of epidemiology at our institute. So we have environmental epidemiology, we have lots of cohort studies, surveys of infectious diseases, health monitors, youth monitors, and also disease modeling and trend scenarios. But we sometimes the toxicologists would sometimes talk to the epidemiologists if some things were not clear for them, but most of them, in the past it was quite a separate world. Of course, we also do risk assessment at the RVM. This includes risk assessments for the environment, for consumer projects, for food. So contaminants are a part of it. It's also natural toxins, herbs, food supplements, and enzyme preparations. And for these risk assessments, in the past this was sort of a very a picture of how risk assessment was traditionally done. So you have a human exposure, and you have a health-based guidance value. And if an exposure is bigger than the health-based guidance value, you have a possible risk. This health-based guidance value was mostly based on animal data, as is also mentioned before. Fortunately, now there's general agreement by now that epidemiological data has the potential to really improve this risk assessment, because it's directly applicable to human health, because it concerns actual humans and not the animals. So you don't have the cross-species extrapolations that were traditionally used in the risk assessment. But of course, then comes the big question: what epidemiological data is appropriate, and how best can it be used? So, to actually get a focus of that, we started the EpiTox work group, and the aim of this work group is, as mentioned before, to work together on the risk assessments using epidemiological data, and those are actually existing nowadays, to share experiences performing risk assessment using epidemiological data, because it's quite a specific topic, and to brainstorm about best practices for epidemiology and toxicology to improve and streamline the use of epidemiological data in risk assessments. So, as a first start in this group, we did some case studies. So we looked at some risk assessment. And we started to identify challenges, the best practices in the use of epi data. So there we have, of course, the appraisal and the weight of evidence parts. We looked at maybe some tips and tricks that could help both sides, and some conclusions and some next activities. I'll go through them. So these are from several risk assessments of all different chemicals, but these somehow always seem to come back in the discussions. So, of course, the big thing is linking the exposure and effect. Often in the epidemiological studies, it's not known to which specific chemicals a person was exposed. There's also sometimes some simultaneous exposure to different chemicals, and how is that taken into account, and also different exposure during different life phases, stages. You also have specific exposure levels that are not known. So sometimes you need to group different exposures for modeling, which makes it more difficult. There's also never zero exposure in a studied population. This is especially true when you look at contaminants that are present everywhere, so you cannot be non-exposed. You have a long duration between exposure and clinical manifestation sometimes. That also makes it more difficult to... we also had a lot of discussion about the size of a studied population. What is a correct size? Because there is clear difference in the opinions of toxicologists and epidemiologists in that. Some more challenges is that the mode of action is not known for all substances. This is of course also the case for animal studies or for new chemicals. The clinical relevance of an endpoint may still be challenging. For example, they have measured an endpoint as a health effect, but what does it actually mean? So is the translation endpoint into DALIs, for example, so it makes it more complex. Data quality and relevance for subpopulations. That was also mentioned before already in the talks. And also, again, dealing with bias. So due to the previous mentioned co-exposure to other chemicals affecting the same endpoint, loss to follow-up, socioeconomic statuses, background contamination, genetic susceptibility, difficult word for me, and publication bias. Of course, the ones that mentioned that sometimes it's very useful to actually know that something is not a risk. And also, the lack of access to raw data, which was also already mentioned several times. We also looked at the weight of evidence for effect determination. We also think that it needs to be clear which questions you actually want to be asked before you even start to appraise something. It's important for evaluation and weighting of individual data, so that's individual studies. You can't just do one big meta-analysis and only look at that meta-analysis. Identification of critical data and endpoints. So you need to be aware before you actually start weighing the evidence which information you actually really need to do it. And determination and evaluation of effect data. Those are the 4 steps, and also it is important for the risk assessment to get these quantitative data and comparable data whenever possible to derive a point of departure, as it's called for the risk assessment, because if you use benchmark dose modeling, you need this data, and ideally you want to do this with individual data, and sometimes there's also privacy issues or non-sharing data, and ideally it would be anonymized individual human health data should be available in ideally, if you could get it from databases. Of course, the NHANES database is such an example which you could potentially get this data out of. You also need to take into account if epidemiologists and toxicologists are talking, sometimes the terminology can differ between the disciplines and methods that they use, so you should always take care when reporting and discussing if you work together, because sometimes that leads to confusion. You also need to take into account that the methods which may be new or adjusted So a new method is used in a newer risk assessment. It should be really, talked about, and it should be carefully and clearly described why they changed it, and a full description of all the uncertainties and the potential impact should be provided, with possible ways to address the uncertainties in the future. Some tips and tricks. So ideally, we would like to establish a publicly available epidemiological databases, and human biomonitoring may improve this usability of this data. For example, if you have a new substance, at least you have now a sort of background. So if a new substance is introduced into this world, at least you have a sort of background level. You also have, it would be nice if raw data could be shared for, it is preferred for benchmark dose modeling, because if you only have, for example, means, which is always accompanied with varying exposures, they all get the same value when you do the modeling, so that's not ideal. And quickly, these are our conclusions. So epidemiology studies provide valuable information for risk assessment. Changes in methodology and reporting of epidemiological studies will improve usefulness of data for risk assessment. And a priori discussion between epidemiologists and risk assessors about study designs will enhance usefulness for the risk assessment. So as mentioned before, it should be discussions, not like you have to do this. More detailed information on exposure, outcome parameters, and study population, etc. are highly desirable. So it could be done if you would actually get the data from the researchers themselves. And of course, again, the access to the raw data for the, to improve the reference point estimation. And individual data is preferred for the BMD modeling, as mentioned before, and establishing baseline of no exposure of new substances. So moving forward, we were still thinking about maybe evaluate a virtual perfect epidemiological study, what is assumed to be perfect by all the members, and then see if there's still some stumbling blocks. And if not, then we could maybe minimize them, and if not, identify harmonized procedures to address the remaining issues. And also identify additional possibilities. So, for example, using human biomonitoring HBM data, and then you can think about can effect biomarkers be used to enhance the use of epidata risk assessment, and also collection of negative for future use again, and are there biomarkers of effects that can improve identification of rare effects or the effects materializing after long exposure? And maybe trying to set up, at least starting, trying to set up these databases I talked about previously. So, thanks. Just in time.
Just speak your closing sentence or remarks.
Yeah.
Oh, then thank you very much for the interesting talk, and sorry for the confusion. And we were listening to a talk from Dr. Sylvia Notenboom, and sorry for this.
Well, actually, I forgot this. This is not, I myself did not do this alone, yes. So there are also a lot of thanks to all the other people that were in the group.
Thank you very much.